Greetings and hello. I'm Dan Little, and I'm so happy to welcome you to this course on what I think is a very important topic, a very interesting topic, in fact, a fascinating topic. I am professor of sociology and public policy here in Ann Arbor. I'm also a professor of philosophy at the University of Michigan Dearborn campus. The topic in front of us is the question of technology failure, and more specifically, the organizational and social causes that contribute to large-scale technology failures. Accidents, plane crashes, nuclear power plant disasters. We're familiar with all of these kinds of incidents, and I think we often have a sense of mystification. How could such a terrible thing happen? Very smart people, very good managers, very good scientists and engineers designed these processes, and yet catastrophic failure. I think the Boeing 737 MAX story of the past year and a half or 2 years is very illustrative because it demonstrates both organizational failure, engineering failure, and also really serious bad consequences for hundreds of people who were killed in crashes and also huge financial costs for the corporation. So the course is focused on identifying the organizational features, the system defects, and the bureaucratic dysfunctions which contribute in many cases to large technology failures. Organizations affect the occurrence of accidents at every level. That is sort of the defining premise of this course. So internal characteristics of organizations like poor communication, what's called loose coupling, a loose relationship between one agency and another agency, and principal-agent problems, the difficulty that exists in coordinating between a supervisor and the person on the ground who's actually carrying out the instructions. These are internal factors which we'll pay attention to. External factors, again, organizational factors, are important as well. Ineffective regulation is a hugely important cause and contributing cause of large-scale technology disaster. The FAA and its failures to oversee the process of redesign of the Boeing 737 MAX, I think many of us in this country came to understand how serious the regulatory failures were in that case. And so in this course, through case studies, and I think very highly of the importance of case studies, through sociological analysis, and through organizational theory, the course will help you to think more fully about safety and accidents in our technologically complex world. You will learn about some of the organizational and sociological insights that talented researchers in this field have discovered, and they're fascinating theories, really interesting theories. Once you've been exposed to these theories, I think you'll see them working in many different contexts, not just big complex technology organizations, but universities and governments and elsewhere. You will also come to see the unfathomably complex nature of many disasters, the many different kinds of causes which contribute to a disaster. And maybe most important, you will gain some tools, some practical tools and some theoretical tools for contributing to the organizations which you will join later in your careers that will allow those organizations to be less prone to accidents and disasters. I've kind of come to realize there's a huge literature on the nature of accidents, how to prevent accidents, and so forth. But I think we can kind of reduce the complexity a bit by focusing in on 4, 5, or 6 theories, or kind of theoretical perspectives. One of those is by the sociologist Charles Perrow, who introduced the idea of normal accidents about 25 years ago in a book of the same title. And so you will read Charles Perrow's book, and it's a very gloomy book in a sense, because it kind of implies that there's no way out, that accidents are inevitable in a complex, technologically intensive society. A second theory that we'll look at is possibly one that you've heard of before. It's Diane Vaughan, another important sociologist who studied the Challenger disaster. And her idea is normalization of deviance. She studied NASA, and she believed that NASA was populated with people of good intentions, highly capable engineers, highly capable managers and supervisors. And yet, by the time the Challenger disaster occurred, practices had gotten way out of line with the original specification of launch criteria and so forth. That's what she calls the normalization of deviance. A more optimistic view is the theory of high reliability organizations. And it's been pointed out by various sociologists and also by a person who's just a brilliant analyst, but also a former student of Perot, Scott Sagan. Research that shows that there are some kinds of organizations, there are some organizations which are way more effective at controlling and limiting and minimizing the impact of large-scale accidents. Nuclear weapons, the control of nuclear weapons, aircraft carriers, unbelievably complex social and technological systems, and yet on the whole they work pretty well. And so the question has been raised, what are the features of a high reliability organization? That's the third theory that we'll look at. Engineers have paid a lot of attention to safety, and one in particular, Nancy Levison, is an astronautical engineer for whom I have a great deal of respect. But she emphasizes the system aspects of safety. She is a system safety theorist within engineering. She worked on the Challenger disaster. She has done just magnificent work in trying to provide a basis for both understanding and reducing the propensity of modern technology systems to result in large-scale damaging accidents which hurt people, kill people, harm property, harm society. So system safety in the hands of Nancy Levison is an important tool. A pair of authors here at the Ross School, Weick and Sutcliffe, contributed to the theory of high reliability organizations. And the book that you'll be reading in this course is called Managing the Unexpected. And Weick and Sutcliffe kind of take the ideas of high reliability organizations and try to put them into practice. How could managers, how could executives do a better job of avoiding disasters when unexpected outcomes arise? And when you've examined a series of cases, you will come to see that the unexpected should be expected because unexpected events happen all the time. And the question is how to respond to them and how to do the best job we can of allowing a nuclear power plant or an aircraft to have a soft landing. And finally, I am a great advocate of the importance of case studies. And Andrew Hopkins is an Australian sociologist who devoted his career to very careful, very extensive, and very thoughtful case studies of accidents, especially in the oil and gas and chemical industries. And his case studies are magnificent, and they kind of cross over a lot of the theories represented by the people I've just been mentioning. And when you put these ideas together, they don't agree with each other across the board, but they give a fairly comprehensive set of ideas about why and how accidents happen, and maybe more importantly, how we can reduce their frequency and impact. And some of the lessons which come out of the study of accidents are deeply important if we're to have a safer future. So what kind of accidents are we talking about? Well, I've got a list of examples here, and we'll talk about some of these in the course. Every single one of them is fascinating to study. But the Challenger and the Columbia Space Shuttle disasters leading to loss of life, not massive loss of life, 6 or 7 astronauts in each instance, but they're tragic occurrences, and they're tragic occurrences coming out of what should be a high reliability organization, NASA. The real tragedy out of these accidents, what emerges is that the same organizational mistakes which led to the Challenger disaster, a handful of years later led to the Columbia disaster as well. It's not the same accident pathway, but it's similar organizational defects. Nuclear power disasters, and every single one of us is aware of Chernobyl, of 3 Mile Island, of Fukushima. And careful study of each of these disasters has shown that organizational features, corporate features, military features, governmental features of the context in which nuclear power plants are designed, regulated, overseen, and managed, those organizational features lead to either better safety or, in these particular cases, almost catastrophic failure. Another set of catastrophes, which is in a sense maybe a little bit less dramatic, but way more common, explosions and fires in chemical plants, gas plants, all over the world. Bhopal, everyone in the room is probably aware of the terrible disaster which happened in Bhopal, India, a gas plant that exploded in Texas City, in our country, in the United States, a disaster at Longford in Australia, which we'll be reading about and looking at, the Deepwater Horizon disaster, which led to the deaths of a few dozen crew workers on the platform, but led to enormous environmental damage in the Gulf. And so one would like to understand what are the failures which led to the Deepwater Horizon disaster. Most recently, the Beirut port explosion, and a handful of years ago, 5 or 6 years ago, the Tianjin port explosion. Very similar histories in those two explosions of dangerous chemicals in a port. Hitting close at home now in the coronavirus time, failures of hospital and patient safety. The fact that U.S. healthcare is, generally speaking, I think pretty technologically sophisticated, medically sophisticated, and yet medical error, hospital conveyed infections, accidents, misdiagnosis, failures in hospitals are quite common. And we're going to read about some of the organizational and system failures which lead to failures in hospital and patient safety. Aviation is a huge area where accidents have major consequences. The DC-10, 25 years ago, the Boeing 737 MAX, the military aircraft, the Osprey vertical landing and takeoff aircraft, which crash probably way more often than any aircraft, military or civilian. But why did these aircraft fail to perform in a safe way? Well, it turns out there were deep organizational causes of these aviation failures. Military accidents are also very interesting. The military is itself a gigantic organization, a gigantic bureaucracy, and so friendly fire accidents, for example, usually have an organizational component. During World War II, way before your grandfather and grandmother was born, I suppose, the United States did a simply abysmal job of designing and implementing anti-submarine warfare with almost catastrophic consequences with German offensive against U.S. shipping. Navy craft collisions in more recent times, the kind of accident investigation and system level investigation, which we'll be talking about in this course, very relevant to assessing and interpreting and then avoiding accidents within a military context. I also include episodes of institutional catastrophe surrounding sexual misconduct. The fact that sexual harassment, sexual misconduct, sexual assault has happened in what ought to be safe and affirming environments, universities. Well, sexual misconduct is way more common than it should be, and major scandals have occurred at Penn State, Michigan State, and now U of M is dealing with its own issues of long-term sexual misbehavior by employees, which was, for one reason or another, never identified and never corrected. This is an organizational failure, and we would like to understand these disasters in terms of the organizational failures which which gave rise to them. So, what kind of sources of failures will we be identifying? This is not a list which is intended to be in any kind of order, but regulatory failure and regulatory capture are ideas that we're going to pay some attention to. The nuclear industry is regulated by the Nuclear Regulatory Commission, the NRC, and it turns out, on careful scrutiny, the NRC is not a very effective regulator of a very, very powerful industry. And we'll see some very interesting examples which kind of indicate that nuclear safety is really not at the level where we would want to see it. There's a whole bundle of organizational failures within corporations and business organizations, management failures. The priority that's given to cost cutting turns out to be often a factor in the occurrence of failures. For example, withdrawing a whole group of engineers from a gas plant because they could be deployed from the central headquarters. That was a cost-cutting initiative, and Andrew Hopkins shows us that it was a direct causal factor in the occurrence of the Longford episode. A misunderstanding of what safety is. Managers and executives who misunderstand safety and think about shop floor accidents, slip and fall accidents, rather than catastrophic failures and system accidents. We will also be looking at the fact that organizations often have internal conflicts of priorities and goals. And we can see that in lots of kinds of organizations, both private organizations, for-profit organizations, but also nonprofit organizations like the International Red Cross. Poor communication within and across units of an organization is another cause of failure, which is often identified. Getting closer to the people actually doing the work in a power plant or other dangerous activity. Poor training was a part of the Bhopal catastrophe disaster. Poor oversight and management, and poor compliance with safety procedures, which, if followed, would be reasonably good procedures, but because there's poor compliance, an accident follows. And then finally, design failure. The 737 MAX failure is an interesting case because it was both a design failure, but it was also a corporate failure, and a corporate failure that had a lot to do with business reasoning about cost cutting and enhancing the stock performance of the company. So what are the intellectual resources which this course will be highlighting for you, in which the field, if there were a field called accident science with its own discipline within the university, these are the kinds of resources that I would be advocating that we would want to be including within accident science. First, organizational sociology. Second, system engineering, the kind of thing that Nancy Levison advocates and develops in her writing. Third, public policy analysis, including analysis of the regulatory process. Another intellectual resource, which is very important in this course, is the development of disciplined, careful, systematic case studies. Taking an accident and not doing what is often done in industry, which is to try to develop an accident tree and finding but for the loss of this element, the accident would not have occurred. Generally speaking, that last moment when an operator possibly made an accident, chose to go left rather than right, headed for that beacon rather than another beacon while navigating a jet aircraft, that last error is often not the most important error. And a more important error would be the management systems, the design of safety systems, which lies in the background. Case studies are hugely important in this course, but I also think, as a philosopher of science, I believe that case studies are a really important form of investigation, kind of empirical investigation into the world. And technology accidents are inherently complex happenings, which can't really be summarized in a short newspaper article. So a case study is a very careful inquiry into the many occurrences which came along, which contributed to the occurrence of the accident or catastrophe. So in order to understand a given accident, a crash, a series of crashes, a nuclear power accident, a power plant, gas and chemical plant explosion, in order to understand a given accident, we need to have a careful, fact-driven, theoretically aware account of what happened. And it is one observation, I think, that comes out of doing safety kind of studying safety and accidents is that outcomes are usually multi-layered in the sense that malfunctions occur at a number of levels. Operators, yes. Supervisors, yes. Managers and trainers, corporate executives, government regulators, and maybe the public. Maybe the public is a part of the kind of social cause of accidents as well. We insist on convenience as consumers, and yet convenience often results in a concentration of hazardous materials which can have very serious consequences. And we learn a great deal about the sociology of accidents by examining case studies by experienced and talented researchers. This is one reason I admire the work of Andrew Hopkins so much. He's a very, very capable sociologist, and he puts his intelligent mind to work on understanding these complex things which happened in pretty mundane places, gas plants, petroleum processing plants, chemical plants, and so forth. Your work will be parallel to that because the primary research activity of this course is team-based case study projects. I've got a list of the projects. They will be up as of the first day of classes next Monday. But what you'll find is a Google document which lists about a dozen possible topics. I think they're all interesting topics. You couldn't go wrong choosing any of them. And the document also gives you some ideas about what ought to go into a case study. You will then work as a team of three. What I believe, what I hope, is that you'll immediately turn to the list of topics and decide what you'd like to work on, then introduce yourselves to the other members of that team. Once we've sorted out, so we've got about 3 people on each team, then the teams can begin to get acquainted, begin to discuss the problem which they're taking on, and begin to divide up the work. The first presentations, we'll have intensive presentations of, let's say, roughly 25 minutes per team. Starting on November 2nd, we'll have 2 presentations per meeting day through the end of the semester. And one thing I can guarantee you, I know this from experience because the first time I taught this course at the Ford School was a year ago. Every team felt that they learned so much from throwing themselves into the details of these truly engaging and illustrative accidents which they studied and analyzed and tried to give a kind of a theoretical accounting of and also a sort of public policy accounting of. So I, once again, welcome you to the course. We're going to spend the first session talking a little more informally about the content of the course, but also try to get acquainted with each other and begin to work together as a group of individuals who are really fascinated at the connections between organizations, policies, governments, and complex activities that our modern technology-based world involves. Thanks for being in this course. I think we're going to have a really great time this semester.